I am Anil Kumar sharing with you a very important playlist on request of students who want to understand how do we write polynomial equation if the roots are given to us as irrational roots or imaginary roots. We'll take up 7 questions, answer some of them in this video and some in the next video.
Our approach, engaging minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here.
Let us now understand the concepts and get ready on this topic. I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, I'll answer question number 6 and 7. I hope you remember earlier we had taken up 5 questions in part 1. So these were the 5 questions discussed. In case you haven't watched that video, you can always go back to that video. I'll provide you the link and you can see or understand the solutions. Now, we'll consider question number 6, which is a polynomial with roots x equals to 1 with multiplicity of 2 and x equals to minus 3 and has leading term of minus 3x cubed. Write the equation in standard form, sketch the graph. What are the end behaviors of your function? That is question number 6. The question number 7 is we need to write the equation of polynomial of the lowest degree in standard form with the given conditions, sketch the graph and describe the behavior and behavior. So this time the question is a polynomial with roots x equals to 2i, x equals to 1 with multiplicity of 2 and x equals to minus 4 and has y-intercept of minus 4. So write the equation in standard form, sketch the graph. What are the end behaviors of your function, right? So that's the question. You can always pause the video, answer these questions. I'll provide you a hint to solve this particular question, right? So the very first one is that we are talking about polynomial with roots x equals to 1. So let's write down as function f of x, or you could write y equals to root at x equals to 1 means x minus 1 is a factor, right? With multiplicity of 2 means square, and x at minus 3 means x plus 3 will be the factor, and that has a leading term minus 3x cubed. So that's the leading term. You can see from here x squared and x will give you x cubed, but minus 3 will have to add here. So that becomes the leading term minus 3x cubed. You get the idea. So that becomes your equation. Now clearly, we have to provide this solution in standard form, right? So that is what is required. So to get the solution in standard form, we need to expand this. So let us now expand. So we get what? We get minus 3 and x squared minus 2x plus 1 times x plus 3. We can now expand this. So we have minus 3 x squared times x. Apply the distributive properties. So we get x cubed plus 3x squared minus 2x squared minus 6x plus x plus 3, right? So that is what you get. You can combine the like terms and then later we'll multiply by minus 3. So we have x cubed As far as square terms are concerned, we have plus x squared minus 5x plus 3, right? Now you can multiply with minus 3. So you get minus 3x cubed minus 3x squared plus 15x minus 9. So that becomes the standard form of this particular equation as required, correct? So that is how you could do it. Now the other terms were you had to sketch this function, correct? So we did this form. Now you have to sketch this function. Let me show you how do you sketch this particular function. So I'll sketch it here, and we'll also discuss the end behavior. So we have very little space here. To sketch the function, I'm going to use the factored form. This is, however, the answer as standard form. Now we know that the zeros are at 1, and at 1 we have double zero, right? Multiplicity, and then at minus 3. So let us say that this is our 0, and that is, let us say, 1 for us, and then here we have minus 3. Since the leading coefficient is negative, we know the right side is going to be down, right? So that is the end behavior, and the left side is going to be up. So that is how we could actually think about the characteristics. And since we have at 3 a linear 0, it means it is going to cross here. However, at 1 it is going to turn. So that is how it should be, right? So now we can actually sketch our graph connecting these points as I'm showing you, right? You get the idea. And on this side, we'll just continue to go up. So that becomes the graph of the polynomial. You get the idea. That is the graph of the polynomial. And as far as the end behavior is concerned, let me write down the end behavior now. End behavior really means if x approaches negative infinity, what value is y approaching? We see very clearly y approaches positive infinity, and when x approaches positive infinity, y approaches negative infinity. So that becomes the end behavior. That is how we are going to answer question number 6, correct? So what we did was we wrote the equation standard form, we sketched the graph, and then we wrote the end behavior, correct? Now let us take up question number 7, which is a polynomial with roots 2i and x equals to 1, multiplicity of 2 and x equals to minus 4, and has y-intercept of minus 4. Okay, so let's take question 7 solution now. So we can write this as y equals to, we have a root at 2i. That means plus minus 2i. It also means that we have a root at x equals to, it should be plus or minus 2i, right? They're always in conjugate pairs. So the factor for this will be what? X minus 2i and x plus 2i, correct? So that gives you from the first factor. Then x equals to 1 with multiplicity of 2. That means x minus 1 squared, and x equals to minus 4 means x plus 4 is another factor. And we know the y-intercept this time is minus 4. Let's write a here to figure out what y-intercept could be. Now, this equation can be simplified, and we do difference of square. So we get x squared minus 2i squared. Remember this, minus 2i. So, sorry, let me write like this. Let me write 2i squared first, right? So 2i squared is equal to what? It is minus 4, correct? So when you write minus 4 here, it becomes plus 4, right? So let me first write this as a squared minus 2i squared, just to make it absolutely clear. The other factors are x minus 1 whole square times x plus 4. Now, we get y equals to a times x squared plus 4, right? Because we know that I squared is basically minus 1. So we got minus 4. Minus 4 and minus sign makes it plus. And therefore, the equation will be as shown here. I'd like you to expand this equation and write the standard form. Perfect. So here we'll actually end this here and find what is the value of a when y-intercept is minus 4. So that means the point is 0 minus 4, correct? So substitute 0 for x and minus 4 for y. So when I do that, I get minus 4, a times 4 times minus 1 square is 1 and then times 4, which is 16a, right? And so clearly, we get the value of a as minus 4 over 16, which is minus 1 over 4. And that gives us the result, and that the equation should be what? So the equation is y equals to minus 1 over 4 x squared plus 4 times x minus 1 whole square times x plus 4. Does make sense to you? So that becomes the equation as such. Now you need to sketch the graph of this polynomial, write down the roots, sketch the graph. So here I will sketch it, make a rough sketch here. We know that the roots are, real roots are at 1 and minus 4. So let's think like this, and 1 and minus 4. So we have, let's say this is one of the root at minus 4, and then here we have a root at 1. You know the y-intercept is at minus 4 somewhere there. Root at 1 has a turning point, and you know leading coefficient is negative. Leading coefficient being negative really means that the right side is down, right? Right side is down. The degree is 2 plus 2, 4 and 1, 5. It is an odd degree polynomial, so that will be up. So end behavior is clear to us. At minus 4, we have a linear 0, and at minus 1, at 1 we have a quadratic 0, and therefore we'll just sketch the graph here. I'm going to sketch the graph kind of like this. Do you see that? So that is how we are going to sketch a graph where this point, the y-intercept, is minus 1 over 4. Is that clear to you? Or minus 4, sorry. So that is the way to sketch your graph, right, for the given function. End behavior. Can you write down the end behavior? Yes, I think you can. X approaches minus infinity. You can see y approaches positive infinity. When x approaches positive infinity, y approaches negative infinity. That is how we are going to describe the end behavior of this function. So I hope you understand that if the complex roots are given to you, how do we write the equation and how do we sketch the graph and describe end behavior. You can do some practice questions. I hope it will be interesting if you take up the examples. In question numbers 1 to 5, sketch their graph, right? So you could extend this, sketch graph, and then describe end behavior. That will be a good practice exercise for you. I hope you find it interesting and useful. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.